Okay, so the diagram below shows a sketch of the curve with equation y equals x squared minus 4. So in A then it says find the coordinates of A and B. And in B then it says find the area of this shaded region. Now think about the process that's going to be involved here. Okay, there's two parts, isn't it? A and B. Okay, they're asking you to start with to find coordinates A and B. And you need to ask yourself about, the question is, well, why have they asked this? Okay, this is different. They haven't asked this before. Why are they asking us for coordinates A and B? What's perhaps that got to do with what we've been doing today? Okay, with the context of this. And I hope you can see that because the process of integration will give us this area, we obviously need to know these values, don't we? Because this will be my lower limit and this will be my upper limit. And I need those values for the integral. So I cannot work out this area until I work out what A and what B are. But you know what? It's quite straightforward to work out what A and B are. Because if you think about A and B, okay, those points there, let's highlight them in particular. Think about where those points are on the curve, okay? On the curve. And we can literally say, look, at A and B, the curve, if you think about it, crosses the x-axis at those points. And what's true when it crosses the x-axis? Well, when it crosses the x-axis, we obviously don't know where it crosses. We don't know what the x values are there. But we know the y value is 0, yeah? So we could say, and on the x-axis, y is equal to 0. Yeah? Because there's no height to it there. You're literally on the ground, so to speak. Okay? We don't know what x is, and we want to find that out. But we know y will be 0. So you can actually look at that curve there and set y to be 0. Yeah? So instead of have y equals x squared minus 4, we'll have 0 equals x squared minus 4. Okay? So we can literally say that, therefore, 0 is equal to x squared minus 4. Okay? Or we could rewrite that and say, look, x squared minus 4 is equal to 0. You can write it the other way around, right? It looks nicer to have it on the left-hand side here. Think about then how we could solve this. And if we can solve this, we can then work out what the x values are. Okay, we can work out what the A and B coordinates are. And it's simple to solve because here we've just got two terms. You could take that minus 4 over. So this means x squared will equal to positive 4. Okay. And then we're going to, of course, to work out x, you've got a square root, haven't you? You could take that square over and square root to the opposite. But when you square root, remember there's got to be plus or minus. Okay. Right? Because it could be positive, it could be negative. And when you square root 4, of course, you get 2. So x is equal to plus or minus 2, basically. So we can see straight away that the coordinate of B will be 2, 0. And the coordinate of A will be minus 2, 0. Okay? So, straightforward way now of finding those coordinates. And then, when it comes to doing the area, shaded region, you literally put those limits in there for A to B. So the lower value there is minus 2, and the upper value there is 2. So when you integrate, square bracket, add a power there, so that's x cubed divided by 3. Minus 4 then becomes minus 4x. No need to write plus c in between 2 and minus 2. So we'll put the limits in and then we'll get our answer, we'll get our exact area. But there's an interesting thing that happens at the end, okay? So you need to pay careful attention to this so that we can interpret our answer correctly. So if we put 2 in to start with, substitute 2 in, you get 2 cubed over 3 minus 4 times 2. Okay? So that will be the first bracket there. Take away then, now careful here because you've got to put a negative limit in, right? So when you put a negative limit in there, we need to say minus 2 cubed, yeah? So that will be minus 2 in a bracket. Put it in a bracket to be clear that we've got a cube minus 2. Take away then 4 times x, 4 times minus 2. So work each of them out. So the first bracket, 2 cubed over 3, take away 4 times 2. And you actually get out a minus answer, minus 16 over 3. Take away then, so let's work out this bracket. So let's be careful with that bracket there. So you're going to put fraction, bracket minus 2 cubed all over 3, minus 4 times minus 2. And you get out the answer to be 16 thirds this time, okay? So last time we had minus 16 thirds out. This bracket we have 16 thirds out, but there is a minus there, okay? And what you should see straight away now is our answer, okay, is a little bit different to what we've had before, because when you've got minus 16 thirds, that works out to be minus 32 over 3, okay? Now, you've got to ask yourself, is that answer acceptable? Okay. Go back to the question, and it says find the area of this shaded region. Okay. Now, can an area be negative? Of course, an area has to be positive. Okay. But in this case, we end up having a negative answer out. And the reason why we have a negative answer out is because we're dealing with the part of the curve that's in the negative section, okay, of the y values. It's going to come out as negative, okay, due to the maths behind it. But what you must do then to finish off, you must say, therefore, the area is equal to 32 over 3. So you literally make that positive. Okay, so you say area is 32 over 3 units squared. So when you have a negative answer out, just say then underneath, therefore, the area, take the positive of it.